Hello and good day, everyone. Welcome back to my YouTube channel. This is Sir Marcy, and our lesson for today is all about inverse variation. Okay, let's define first what is an inverse variation. The statement y varies inversely as x means that when x increases, y decreases, or vice versa by the same factor. This occurs whenever a situation produces pairs of numbers whose product is constant. In other words, the expression xy is constant means x times y is equal to k, where k is the constant of variation. The statement y varies inversely to x translates to y is equal to k all over x, where k is the constant of variation. Take note also that the graph of an inverse variation is not a straight line. Okay, let's try to translate the following statement to mathematical equation. Use k as the constant of variation. Number 1, the amount of time t traveled when driving a car varies inversely with the car speed s. If we're going to translate this to mathematical equation, that is the same as t is equal to k all over s. Number 2, the time t it takes to paint a room varies inversely as the number n of men who will paint it. Okay, you are correct. The answer is t is equal to k all over n. Number 3, the cost each one pays for a field trip varies inversely as the number n of people joining. That is equal to c is equal to k all over n. Number 4, the frequency f of a radio signal varies inversely as the wavelength. That is f is equal to k all over w. Last number, for a fixed total cost, the number n of items purchased varies inversely as the cost c of one item. That is n is equal to k all over c. Let's now try to determine if the tables and graphs below expresses an inverse variation between the variables. If inverse, find the constant of variation and write the equation of variation. So in our table number 1, let's try to figure out first the constant of variation. Take note that to find the constant of variation, it must produce pairs of numbers whose product is constant, or simply k is equal to x times y. Here, let's try to first figure out our k, or the constant of variation. So we multiply 36 times 2, that is 72. Next is 8 times 9, that's also 72. 24 times 3, 72, and 12 times 6, also 72. Therefore, we conclude that this is an example of inverse variation. That means the value of k is equal to 72. Next is, after finding out the value of k, we will now find or write the equation of variation. To do that, from our general equation, y is equal to k all over x, we will just substitute the value of k. That is now y is equal to 72 all over x. And this is now the equation of variation. Next is, let's try to figure out table number 2 if this also expresses an inverse variation. So again, we find the constant of variation by simply multiplying x times y. 24 times 6 is 144. Next is 49 times 7, that's 343. 72 times 8 is 576. And 18 times 9 is equal to 162. Notice that the value of k here is different from each other. Therefore, we consider this table or example number 2 not an example of inverse variation. Let's continue. This time I have two graphs. Let's try to figure out which one of these exhibits an inverse variation. Now, in graph number 1, notice that it is a straight line. So if you remember, by definition, the graph of an inverse variation is not a straight line. So therefore, we conclude that graph number 1 is not an inverse variation. Next is, let's try to examine graph number 2. Although it's not a straight line, we cannot determine yet if this is an inverse variation. First, we need to figure out the value of our constant of variation. And to find it out, you just simply multiply x times y. So here, our ordered pair, that's 1 times 16. The answer is 16. 2 times 8, 16. 4 times 4, 16. 8 times 2, 16. And 16 times 1, 16. So therefore, we conclude that our constant of variation k is equal to 16. That means this graph is an inverse variation. Since it's an inverse variation, we can also write the equation of variation. From y is equal to k all over x, we just simply substitute or plug in the value of our k, and the equation of variation now is y is equal to 16 all over x. Okay, let's try to write equation where y varies inversely as x. So in number 1 problem, we have y is equal to 10 when x is equal to 1 half. So again, our first step is to find k. So to solve for k, that is k is equal to x times y. The value of our x here is 1 half and our y is equal to 10. So 1 half times 10, our k is equal to 5. Meaning to say, if we're going to write the equation of variation, y is equal to k all over x, that is now y is equal to 5 all over x. And this is our equation of variation. Next, let's have example number 2. We do the same procedure. First is we solve for k, that is x times y. That is 0.4, 0.3 multiply to 0.4. So when you multiply this, the product of 0.3 and 0.4 is 0.12. And this is our constant of variation. Next is our equation of variation, y is equal to k all over x, is now y is equal to 0.12 all over x. Okay, for our last example, we have k is equal to xy. That is 3 multiplied to 12. So our constant of variation is 36. Our equation of variation is y is equal to kx, and that is now y is equal to 36 all over x. Our last slide, I have here some application of inverse variation in real life. Okay, number 1 is that the number of persons sharing a pizza to a number of slices of pizza. Next is the number of days required to build a bridge varies inversely to the number of workers. As the number of workers increase, the number of days required to build will decrease. Okay, so I hope that you learned something today. I hope to see you soon and goodbye.